Hello, everybody. Welcome to lesson 2, class starter. I hope you tried the class starter first before coming here to look at the answers, but I'm about to go over the answers. So the first step, after you've read the question, of course, is to make yourself a set of free body diagrams. Here are my free body diagrams. You can see that the question has 3 bodies connected by 2 ropes. I've labeled those 3 bodies body A, B, and C. You can call them whatever you want. I chose A, B, and C. And that there are 2 ropes. And so if there are 2 ropes, there's going to be 2 tensions. So the tension here, I call tension 1. And the tension between B and C, that's a separate physical piece of rope. And so I'll have a different tension. I call that T2. Okay, tension 2. Now, the 3 free body diagrams then that you can see here, I'm just going to see if I can reduce my size just a little bit there so you can actually see the third one. In the first one here, you have 4 forces acting on this 4 kilogram object. Of course, a force of gravity, which is met equally with the normal force of the table pushing up. And since those 2 forces are balanced, I will indicate as so. We have a tension 1 pulling this way, and so I've called that here force of tension 1 pulling to the right. And then, of course, as it slides across the table, there will be a friction force opposing that motion to the right. For object B, we have 2 forces down. Of course, there's a force of gravity, which I calculated to be 19.6 newtons down. And also there is tension 2, the rope pulling it down as well. Pulling it upwards is a rope. We call that tension 1. And so 3 forces on object B. And then finally on object 3, there are 2 forces, a gravity pulling it down, which I calculated to be 39.2 newtons. And then, of course, a tension force upwards on T2, right? So here you can see force T2. Now, the next thing I'm going to do is I'm going to calculate the net force for the whole system. And when I do that, I like to remind myself that I'm calculating for the net. So I actually write F net for the system. So here we go, F net, and the little s represents system. That always equals to forces supporting minus forces opposed. Now the supporting force in this case are any force that's going to have the object travel in the direction that it's going to move. For object A, it's going to move that way. And so FT1 is supporting. For object B, it's going to go down. So force of gravity B and force tension 2 are supporting. And for object C, oh, I didn't label it C. Let's do that now. It's going to go down. And therefore, force of gravity C is supporting. So let's put those all as our supporting forces. Whoops, wrong color. So here we go, force of gravity C added to force of tension 2 plus force of gravity B plus force of tension 1. Those are the supporting forces. All the forces opposite to the direction of the arrows of motion will be friction on A, tension T1, and tension T2. So let's put those in as our opposing forces. Force of friction on A, force of tension 1, and force of tension 2. Okay, now, what you'll notice about when you do system F nets is the tension forces cancel out. Because here we're adding T2, and over here we're subtracting it. And here we're adding F of T1, and over here we're subtracting it. So they cancel out, leaving us with the following. Force of gravity C, 39.2. Let's make sure that looks like a 9. .2 added to force of gravity of object B, 19.6 minus the force of friction for A, which I haven't calculated. So let's go back and do that. Force of friction is equal to mu Fn. Mu in the question is 0.25, and the force normal is 39.2. And then on my calculator, 39.2 times 0.25 is 9.8. So now I'm going to subtract 9.8. Well, let's see if we can get that in the right color. There. Okay, let's find my Fnet for the whole system. That's 39.2 added 9.6 and then subtract 9.8. That gives me 49 newtons. Okay. Now I'm going to do Fnet. It's equal to mass times acceleration. Now this is Fnet for the system. So I will need system mass. There are 3 objects in the system: a 4 kilogram, a 2 kilogram, and a 4 kilogram, which adds up to a total of 10, right? 8 plus 2. And this is 49. Don't need a calculator for this. 49 divided by 10. Acceleration is 4.9 meters per second squared. Now, that's one of the things I was asked to find, the acceleration of each object. And that means object A is going to accelerate to the right at 4.9, B is going to accelerate downwards at 4.9, and C is going to accelerate downwards at 4.9, right? So there we go. First question done. Now the second question is to find Ft1 and Ft2. And to find the forces, we're going to look at individual bodies, not the whole system, just one little body. And to find Ft1, I'm going to use object A, because it's a simple calculation. To find Ft2, I'm going to use object C. Now, please note that when I use object A, I use it because we know everything about these forces except Ft1. And when I use object C, same thing. I know force of gravity. I don't know force tension 2. I can figure that out. I'm not going to select object B because there's 2 unknowns. I don't know tension 1 and I don't know tension 2. So select these 2 instead. It's just easier, right? Okay, so working in object A, I'm going to calculate the net force on that object alone. Okay. Here we go. Fnet is equal to mass times acceleration. Object A was 4 kilograms times 4.9. I almost wrote that backwards. And that will be 19.6 newtons. Okay. And then for A, remember we're just doing this for object A. Oops, sorry. Want the supporting force for A was force of tension 1. The opposing was friction. Right? Let's go back and have a look. Force of tension 1 supports, friction opposes. Okay, so force of tension 1 is what I'm looking for. Friction, we calculated up here, was 9.8. And our Fnet is 19.6. Find force tension 1. So I add 9.8 to both sides. That gives me a roughly 29.4 newtons for force of tension 1. Okay. Now, for object C, change the color to black here. We're going to do the same thing. But this time we're doing it for C. Okay. So the mass for C is 4. Again, times 4.9 again, which is 19.6 newtons. F net for object C is forces supporting minus forces opposed. Let's make that neater. Supporting force in this case is the one that's downwards. Let's go back up here and look. See, force gravity is supporting, and force tension 2 is going to be opposing. This is 19.6. Force gravity we know to be 39.2. So force of tension 2 is equal to, subtract 39.2 from both sides, I get negative 19.6, but that negative 19.6 is equal to negative FT2, so the negatives cancel, so we have 19.6 newtons. All right, so there they are, the answers for question 1. And I'm just going to make it smaller so you can see the, whoops, wrong way. So you can see the whole question at once. There. Okay. Now, just give me a second while I go ahead and make the free body diagrams for question 2. All right. Okay, so you can see I've done some free body diagrams here. M1 is in green over here and M2 is in red over here. Please notice at M1 that if this angle here is 28 degrees, then this angle here, which is between the vertical force of gravity straight down on M1, that force of gravity would be like this, right? And the X and Y components of that force of gravity, here and here, make a triangle where this angle here is always the same as this angle here. Okay, so that's typically the case. So you can see that I've got 28 degrees in here because it's 28 degrees there. So I calculate this force of gravity here. Force of gravity is 49. And then I calculated for the Y and X components. Here they are, using sine and cosine. And since the Y component is directly opposite to and equal to the force normal, let's indicate that. Tick, tick. That I used the Y component, the 43.26, to calculate the force of friction, which came out to 17.3. Okay. Now on this side, it's a much more simple situation. We simply have a hanging object with a wire passed over the pulley here in red. The object has force of gravity down and a tension force up. Simple, easy. Okay. So when the system moves, when released, and we assume it will move when released, this object's going to move up the incline, clearly, and this object is simply going to travel straight down. So any forces acting in those two directions, up the incline or straight down for object M2, will be supporting. Our first step then, as usual, is to calculate the overall net force on the whole system. So here we go. F net for the system is equal to forces supporting minus forces opposed. And the supporting forces in this case will be force of gravity on object 2 and force of tension 1 on object 1. So Ft1 and force of gravity on object 2. opposing objects, or opposing forces, sorry, will be force of tension 1, force of gravity in the x over here, and force of friction over here. So force of tension 1, force of gravity in the x on object 1, and the force of friction on object 1. Okay, now let's put in numbers for those, keeping in mind that when we do the whole system, it's typical for the tension forces to cancel themselves out. So leaving us with force of gravity on object 2, which is 196, minus the force of gravity in the x and friction, which is 23 and 17.3. You'll notice I didn't bother to deal with sig figs. I know I'm going to do everything here to force sig figs. So picking up my calculator, 196 minus, whoops, that's 195. 196 minus 23 and subtract again 17.3 equals. I got 155.7. Okay, and then to find the acceleration of the system, same thing, F net for the system is equal to mass times acceleration. Except the mass, there are two objects. There's a 5 kilogram object and a 20 kilogram object with a total mass of 25 kilograms. This is 155.7. So I'm going to divide that by 25 and I get 6.228. That's meters per second squared. And that's one of the answers we were asked to find, the acceleration of the system. Okay. We were also asked to find the tension 1. Now, again, you can do tension 1 for either of the two objects. It doesn't make any difference. But if you look at the diagrams, tension 1 for object 2, the red one up here, will be easier to get simply because the diagram's easier. Only 2 forces, whereas this one's got 4. So let's pick this object over here and find the net force for that object alone. Use that net force to find this tension. Since I already know that it's accelerating down at 6.228, I can solve for that using this. Force net is equal to mass times acceleration. I know the mass of that object is 20, and the acceleration is 6.228 downwards. That's an acceleration of, or that's an F net of 20 times 6.228. 124.55. That's in newtons, right? And then F net for object 2 alone is equal to forces supporting minus forces opposed. Well, the downwards force movement is supported by the force of gravity, and the opposing force would be force of tension 1, which we're looking for. So we know F net here for object 2 is 124.56. Force of gravity was, let's go back and look, 196. Force tension 1, subtract 196 from both sides, and I get force tension 1 is equal to 71.44 newtons. Hopefully I haven't made any mistakes. There's our tension. Okay, so 2 body systems. Again, one of the main things to remember, of course, Newton's second law, F net is ma and F net is force supported minus force opposed. And the second thing to know about 2 body systems is when you look at the whole system, typically tension forces are going to cancel out. And so in order to calculate tension forces, you'll need to look at a single body like I did here for object 2 to find the tension force. Okay, all right, that's the completion of the class starter.